she's an architect, and she's been working with fabric formwork. Hello, Scarlett.
Hello. Hi.
And where are you this morning, Scarlett?
I'm currently staying in South Korea because sadly architecture school in Edinburgh has closed since March due to the pandemic. So I'm currently working on my own project in the garden of my own home here. So I'm really lucky to keep working on my project here.
Fantastic. And so I'm just gonna let you get on with it. Very happy that you're here all the way from Korea. And
thank you.
Scarlett was going to talk for 20 minutes or so, and then Peter following will be another 20 minutes, and then there's a question and answer at the end of that. So, but I'll check back in with you all before then.
All right, good. Okay. Let me share. Okay. Can you? Okay, just a second. Oh, no. Can you see the full screen of my presentation now?
Yes, that's great.
Yeah, good. Thank you. Hi everyone. My name is Scarlett Lee. The title of my I'm a PhD student at the University of Edinburgh, and the title of my session today is Flood Resilient Earthen Construction Technology and the Case Study of Pakistan. I'm proposing fabric foam round earth as a sustainable housing solution in flood-prone areas. Let me start my session by briefly explaining you about the background of how vernacular earthen construction technology has delayed by giving you some example of Pakistan. The image on the left is a house of the Mohenjo-daro during Indus Valley civilization. The Mohenjo-daro is one of the first civilization, and it was built around 2500 BC, which is the same time when the Great Pyramids were built in Egypt. The image on the right is a typical contemporary house near the Indus River in Pakistan. What is interesting to see here is that vernacular construction technology in Pakistan has not changed since the first civilization. Both of two buildings are built with wood, reed, and mud plaster. The problem is that the delayed progress of vernacular earthen construction technology, coupled with climate change, is endangering earthen dwellings in developing countries, especially in flood-prone areas in Pakistan. So I researched why earthen houses in Pakistan collapse in floods. This chart is the affected housing, the flood-affected housing typologies in Pakistan. As you can see, adobe and mud houses are most heavily affected type, taking up to 57%, and this proportion are becoming higher in southern flood-prone areas in Pakistan because wood and stones are scarce. The problem is that mud and adobe houses are built with low compaction, so they are susceptible to rainwater and flood. And also, one of the cause of collapsing of mud houses is due to the roof construction. Regardless of housing typologies, most of housing typologies in Pakistan have flat roof and plaster with mud layers. The problem of the use of mud as roofing material and flat roof is giving negative impacts on structural integrity, because mud is waterlogged by excessive amount of rainwater during monsoon season. So it causes roof and walls are collapsed. And image on the right side is one of the example of the absence of foundation in mud housings, because most of mud houses built without foundations, so they are very susceptible to flashing rainwater, eventually causing mud houses to be collapsed. So I have initiated my research to develop flood-resilient earthen construction technology. One of the major reasons why COP and adobe houses are popular in Pakistan, despite of the fact that they are very vulnerable to flood, is due because they are the earthen materials are affordable and locally and available. So I'm proposing round earth because they are the highest compacted earthen structure, because they are created with a high compaction, reducing the gaps between soil particles. But the problem of the traditional round earth is because they are built with timber formwork. So timber is very scarce in flood-prone areas in Pakistan. So this technology is not really easily found or developed in Pakistan. Therefore, I asked the research question, could fabric be low cost and flood resilient formwork instead of timber? So I conducted some tests to demonstrate the flood resilient feature of fabric formwork in the lab test. And the aim of this lab test was to compare the density between fabric formed round earth and timber formed round earth. Both sample was created with about 20 centimeter height, and in order to distribute the same amount of compression to each specimen, the rammer was hit with a hammer above or shoulder height. In the first test, I use a square-shaped rammer to compact the fabric formwork. But as you can see on the middle second image, the edge of fabric formed round earth was not properly rammed because fabric was burst during the ramming course. So I conducted a second test by altering the profile of rammer as a rounded shape. And as you can see, the first row is the first test specimen, and second row is the second test specimen. And as you can see, the smoothness of fabric formed round earth is noticeable between first and second test, and fabric formed round earth was built with a larger amount of soil mixture compared to rigid formwork because fabric was burst during the ramming course. And these specimens were dry in the lab about 2 months by checking their weight periodically. The formula for finding density was created by dividing weight with volume. And these two charts show the density of these of specimens. In the first task, you can see that timber foam round earth actually has a higher density than fabric foam round earth. But in the second task, the density of fabric foam round earth is almost identical with timber formed earth, although more amount of soil were used to create them. So this task demonstrates the hypothesis that fabric foam round earth helps to create a higher form of round earth because excessive amount of water and moisture, water and air are extracted through the pores of fabric. And I also conducted some research about to find about flood resilient feature of fabric formwork. Actually, fabric formwork has been not widely, but quite well developed in concrete construction. In 1922, fabric formwork was invented as a waterproof container for underwater concrete foundation. And also fabric formwork can be used as a permanent reinforcement for round earth. I will further develop about these features in the next research. And oh, excuse me, let me just drink some water. All right. And textiles are also locally available in Pakistan. Especially textile mills are widely distributed in the southern floodplains. It means that the use of textile will enhance the local economy, but also extends the scope of engagement to women because they are excellent at this task. Then I also proposing that fabric formwork is really portable and flexible feature because fabric is lightweight, so it can be prefabricated and move it to the construction site immediately, minimizing the cost of assembly or labor force. And I made some sample to explore the flexibility feature of fabric formwork. On the one side of facade was created with rigid synthetic fabric with a wooden frame, and the other side was created with spandex and rigid polystyrene molds. The outcome of the model was pretty outstanding because the facade created with rigid synthetic mold with suppressed by wooden frame have a kind of wrinkle, kind of a fabric-like texture, and the other side was created with create kind of a rigid form by catching the fine details of polystyrene molds. I think that this flexible feature of fabric foam round earth is really beneficial for designing aerodynamic round earth walls because they are less impacted by rainwater and wind. And I developed a second task. In this test, I designed I explore how dart pattern could influence on the shape of fabric foam round earth. Actually, darts are mainly used in the fashion industry to design the clothes to wrap around the human body. But in this task, I explore I wanted to see the impacts of dark pattern on round earth. So I drew the pattern to carefully thinking about where I want to saw, and I use a sewing machine to do that. And I just sit on the completed dark pattern fabric on the timber frames, and then the outcome of fabric form round earth was quite subtle, but it captured the concave and convex pattern of dark patterns. And if you can see on the left hand side, the it captures some wrinkles and fine details of dark patterns. And I conducted some tests by being interplaying between computational design and model production to design flood climate resilient round earth. I did some little project in for my lovely dog in South Korea. So first of all, I designed the kind of dome-shaped dog house because dome is structurally stable, and so I designed a 3D model of the house, and then because as you can see, the dome shape is actually slightly tilted from bottom to top. So I plan to have second phase of construction to complete the project. So in the first phase, I laid out the three-dimensional wall of the bottom as a planar figure, and attached the and then printed the planar figure was attached to the PE fabric. And I saw the fabric. I saw the folded edge of fabric to create kind of a hexagonal shaped wall, and also saw the edge to prevent from being frayed. And I also use use 3D modeling to design fabric former. Actually, this process was very useful to carefully thinking about where I have to put rigid, vertical scaffolding to control fabric is burst too much, and also carefully thinking about how I can assemble and how to disassemble. And I also did some environmental analysis, especially about wind. As you know, earthen architecture is affected by rainwater. So round earth is, so I had to carefully design where opening should be located to get a minimum amount of rainwater. So based on the data, I located the fabric, completed fabric formwork facing to the south, as you can see, because southern part has the lowest, has the weakest wind force. And I did a ramming course with a rounded rammer. And I put a mesh, I put damp-proofing coals and mesh during the ramming course, and also put some lime stabilized mixture to bottom and top. And during the ramming course, moisture, and even after ramming was finished, moisture was extracted through the pores of fabric. Actually, it helps to increase the density of fabric foam rounders. And on the image on the right, the curvature of vertical frame help to create a kind of help to control the fabric is purged, but also create kind of undulated rounder facade. I was able to dismantle fabric former quite easily, and as you can see, the fine details of fabric was really well embedded on the rounders, such as wrinkle and even the woven texture of fabric. So this is the outcome of a rounders wall of first phase. As you can see, the shape has very undulated form, not having any sharp edge except to the top part where timber frame was used. This is a close-up image of the wall, and and then I'm expecting that this really fluid curvature of fabric formwork will really helpful for creating fabric form rounders, especially in flood-prone areas, because they are much less impacted by rainwater or wind than sharp edged wall. So let me finish my session with a conclusion. So I giving you some background about delayed progress in vernacular technology and climate change are endangering earthen dwellings in flood-prone areas. So I'm proposing fabric foam rounders as flood-resilient construction technology, because they are because this technology is flood resilient, locally available, community-driven, portable, and flexible. And I'm also using digital design and data to design climate-resilient rounders. Eventually, the goal of this research is to deliver the technology through construction to empower our local community in Pakistan or any place which they are having some similar contexts like Pakistan. So thank you so much for listening to my session, and you can find the progress on my project and my blog below. Thank you.
Thank you, Scarlett. Wow. There's a lot in it. It's not the same sort of look and feel as regular rammed earth, and there's not a lot of people that you can talk to about how you do it and things that you can play around with. And I do remember that just very subtle changes in the fabric can have a big effect on what you produce and how you're producing it. Mm-hmm. So I'm sure there's going to be some more questions about that as we get into the question time. We've just run